There are multiple activation functions. Like here I have mentioned some of them are linear and non-linear. So first one is we'll go about sigmoid function. Okay, what it is trying to do it is trying to have the values, no matter how much negative it is or how much positive it is, you're trying to squish that value in between 0 and 1. Okay, and this is useful, okay, when you wanted to classify the emails as a, one example I can give you is when you wanted to binary kind of classification problems you wanted to solve, that's where you use the sigmoid function because it gives you a 0 or 1. Okay, you might not use it for the deep networks, okay, or on the hidden layers actually. Okay, the second one is about tanh. Okay, tanh is another activation function, okay, which is mostly used in the sentiment analysis type of problems. Okay, that's where the tanh gets used. As you can see, it squishes the values in between minus 1 to 1. Okay, and it has certain disadvantages. We will see that vanishing gradient descent, which we will see it in the what is gradient descent in another chapter. But for now, you remember that that is the actual use case for which you can use the tanh. The other one is ReLU. Okay, it is a rectified linear unit. It maintains your linear equation. Okay, and it is used mostly into the image classification, and we will be using when we will actually learn on our CNN models. Okay, that's where ReLU gets used, and as you can see that it's bring down the value anything from negative, okay, to a 0, and positive. It has no limits actually. It can consider any input as a positive. And the fourth one is leaky ReLU. Okay, here what you have seen is that anything in negative, it is bringing down to 0. So what happens is in this case is um, every time if a neuron is getting a negative value, it is trying to squish that, okay, and set it to 0. So what happens is there are certain neurons will never get activated if you apply a ReLU on that, and that problem exists. So what happens is those neurons will never learn also, okay, and they will not contribute to your prediction also. So if you wanted to avoid that problem where the value can remain, okay, in negative also it can remain up to some extent, that's when you use the leaky ReLU because you wanted to avoid that dead neurons problem. If you want to avoid, that's when the leaky ReLU is used, and it is mostly used into the voice recognition. That's when the leaky ReLU is used. The fifth one is Softmax. Okay, in Softmax, basically, as you can see that it tries to squeeze it and form, okay, transforms a vector numbers into a vector of relative probabilities. As you can see that if you're getting a value around 5, 6, 11, and 7, you know that 11 is quite a large value, and you wanted probabilistically you wanted to see what outcome your neuron should be throwing and what probability you should be clearly pointing out. Okay, if you wanted to convert that, that's when Softmax is used, and you can see that the probabilistic way it is trying to show that rest of the things it is brought it to 0, and it is prominently show that this is your possible value and probabilistically this is the one is what you are looking for, and this is the actual um, value you should be going after, and this is what the prediction is from this model. So that's about all these activation functions. We'll see in the next chapter how we arrived to this, and we will also learn about linear functions.